Cisco Secure Equipment Access is a product that is providing a zero trust network access solution for OT and industrial networks. Let's dive into what it can do and do a quick demo. My name is Emmanuel Taichon, and I am one of the technical marketing engineer from Cisco IoT business unit, and I'm working on this product. When you carefully consider what IT and OT user want, they actually have very different objectives. Those that are from the operational world, they want efficiency. They want to make sure they can get instant access to remote devices without knowing too much about protocols and authorization and IP addresses and things like that. They want to be able to grant access to third parties, to machines, not to devices and IP addresses. They're not interested about that. They want to be able to provide remote access depending on the need, quickly and swiftly. Also, for auditing purpose, they would like to get access to the audit trails and see what happens. On the other side, the IT guys are typically looking for cybersecurity, and they want to make sure that authorized user can, and only authorized user can access the assets. They want to make sure there's like a multi-factor authentication. They want to make sure that the remote computer is not infected by viruses or malware. They also want to make sure that the architecture, the deployment is simple and avoid complicated VPN with access list and concentrator that can be a little painful to set up, let's be honest. And like the OT guys, they would like also to have a history, a recording of basically what happened, and why not having a screen recording of what the remote user has done for forensics and further analysis. You have heard the word ZTNA multiple times already, but what does that really mean? ZTNA is an architecture, and Cisco Secure Equipment Access complies to that architecture. And what does that mean, ZTNA, in a few words? First of all, it assumes a least privilege access, which means by default, users have access to nothing unless explicitly permitted. If you think about it, that's very different than VPN. In VPN, you get access to everything, unless you have an access list that is preventing or removing or restricting that access, which is great for remote workers, but not so great for accessing remote OT assets. Then second, you can only see the assets you have access to. You cannot run a discovery and see what other machines or piece of equipment are being installed on site. Also, the solution is supposed to prevent lateral movement. So there are a number of contexts and mechanic and authorization that is preventing the user to see and access other equipment that they're not supposed to access. And that is made by restricting port numbers and protocols and IP addresses. Then also it does a posture assessment, a posture compliance. What does that mean? When a remote access user logs into a ZTNA enable remote access solution, we want to make sure that this is really the user and not some bot or malware that is trying to abuse the system. So we do a compliance and we verify that the computer has the required operating system version, that it has a firewall running, it has an antivirus running, and things like that. We can also schedule groups for specific time and specific period of time. The reason why we do that is when you grant someone access, it's an emergency. We absolutely need to grant that person access. Very often you forget about that access, and this person keeps the access forever because we're all human. We make mistakes. We can't think about everything. So the best way is just to never have groups of access that last forever, but instead that are limited in time by nature. Doing so, we are vastly reducing the attack surface, only exposing what is required. It is more flexible. It is more responsive for both the person trying to access the asset, but also for the person setting up the asset, putting the flexibility for OT and peace of mind for IT. So you may ask, hey, Emmanuel, how does Cisco address this problem for ZTNA? So what we do is we're building secure equipment access right into the Cisco industrial portfolio of switches and routers. So there is nothing additional to install. You don't have to install an appliance or some sort of gateway. You can reuse your existing switch and router and use SCA on them while they are cloud operated. So previously, you used to have maybe different switches from different vendors, some of them connected to your network, some of them connected over cellular, and you don't really know who get access to what at which moment. That's over. With SCA, you have one single pane of glass to grant and provide access to everyone from the cloud using that trusted middle broker. So in summary, Cisco Secure Equipment Access, which is part of another product called Cisco IoT Operations Dashboard, is a cloud-based remote access solution that complies with the ZTNA architecture and offers a cloud-based central broker where you can configure your remote access policies and your users, and that is a place where you can give access to specific assets to specific users at a specific time and record everything of what happens. It's very easy to install and it's very easy to scale because it's cloud-based. It's fundamentally very easy to use. There is nothing really to set up other than adding your gateway to IoT Operation Dashboard. And then after that, you can connect to your assets from i.e. industrial Ethernet switches or IR industrial routers and securely access it from anywhere in the world. Let's dive into the demo. All right, I'm logged into Cisco IoT Operations Dashboard, and underneath that main cloud service, I have a number of sub-services, for example, Secure Equipment Access, but there are also others. Here in System Management, I can see the number of devices that I have already enabled SCA on. To enable SCA, select Add a Network Device, select which one from IoT OD you want to enable the service, click Next, and you're done. In this case, I'm going to show you on an IE3400, which is an industrial switch, ruggedized switch. You can see the name, you can see the switch model, you can see that the SCA agent, which is the application that runs on the switch that communicates with the cloud and enables the service to exist, is over here. As a person, as an IT person, I want this switch to be able to communicate, for example, with a PLC. In this case, I have added a PLC, which is over here. It is a Raspberry Pi, but you get the idea. I'm going to click on that, and it has an IP address out here that I have already created. 192.168.2.104. So that's the private IP address of this device connected to the switch. So that's what we call the device itself, right? The network device itself. But the next question is, how do I access this device? And this is what we call access methods. The first one here is by using simply SSH. And I have created another one here called SCA Plus, which I'm going to talk about in a few minutes. But SSH simply means I am adding an access method with this IP address. I want to use SSH on port 22, and I can even enter my username and password out here. Okay, so now I have one switch, I have one PLC or one device, whatever that is, and I have one way of accessing the device, which in this case is SSH. The second is the access management. Who get access to what? And you can create different groups with different access privilege. For example, you can also do a search here. So let's look at the groups. For example, with the word demo in it, we have a group here. So the group is defining who gets access to what. So there's a list of users, and right now there is only me in there, and what can the user access, and that's the two access method we've created previously. So I can access those two access methods. Also, you can change the date. You can have it defined to a specific period of time you want to provide access to. So by editing the group, you can also schedule the setting and say, for example, I want only to enable this group this afternoon or tomorrow. So this way, make sure that when you use external users, when you add external users, you always use the schedule within the group like that to make sure your users don't keep access forever. You can also enforce monitoring and recording. So in this case, I'm doing inline recording, which means everything that I will see here as part of the SCA demo, all of this will be recorded, and I'll show you how to do that. Okay, I am now a remote OT user. What I see here is only access to those remote sessions. So I have one SSH session that I was given access to in the access management just before, and another method that we will talk about in a second. If I click on this tile over here that will start SSH, look at what happens. It starts an SSH session, while SSH does not run on this machine. What you see here is an SSH session that runs in Cisco IoT Operations Dashboard Cloud, where SCA is running. SSH runs from there. What I see here is essentially a video rendering of that SSH session. I may not even have SSH on this computer. The advantage is that it provides complete IP isolation between my computer, the remote access user, and the actual equipment. I can do things, I can type commands, but I cannot transfer files or malware or anything that would harm the system. So here, for example, I can start a number of command. We'll start the screen command, then check what we have. Then we'll start a Modbus server. I'm sure most of you are probably already familiar with what Modbus is all about. So now we're going to start the server that is listening on port 502 TCP. So that's the standard Modbus TCP protocol. All right, so that's what we've done on this Raspberry Pi that in this case is acting as a PLC. But you may wonder, hey, Manuel, that's great, but how do I use my native Cisco application with that? And here comes an additional flavor of SCA, if you wish, which is called SCA Plus. So SCA Plus, and I'll show you how it works. SCA Plus is using a number of specific protocol. It is exposing port number and TCP connections directly on your computer, so that you can use your native client applications. You're not restricted to use just SSH or just Telnet or just RDP. You can use a PLC programming software. You can use file transfer protocols or anything like that. You can define your own. For example, in my case, I have defined a Modbus TCP custom protocol. And with this one, I have enabled TCP 502, and I've also allowed ICMP ping packets. Okay, so that's my custom protocol. I can have multiple ports open, multiple protocols, all of them, and this is your choice. Now, how do we do with this? If we go back to the switch that we had previously, and to this PLC that we had previously, I can define a new access method called SCA Plus. And for this access method, I want to define that the way I want to access this asset is not SSH anymore, is Modbus TCP, the very protocol definition I've just done on the previous step. But because this requires to expose TCP connection to this machine, to my machine, then we need the help of a little agent, what we call the SCA user agent. So how does that work? Go to remote sessions on Raspberry Pi, going back here. As you can see here, I have a toggle button that I can swipe. If I enable that button, it will enable the SCA Plus access method over here. But because it requires the agent, I first need to download, by clicking on this button, download and install the SCA Plus application for this computer. I've already done that, so I can directly enable this. So I turn on the toggle. What happens is that now we're doing posture assessment. Cisco Duo is validating that I am authorized to access this. It's also validating that I have a proper operating system, that I have an antivirus running, that my computer is in good health, and that everything is good and dandy and I can access that device. Now you see that the slider is enabled and also the Duo logo is in green, so everything has been verified and the posture check has been completed. My computer is sane, is safe, and can access this asset. So now if I click this, nothing happened. The reason why, it has just opened a TCP connection, or at least exposed a TCP connection on my computer. It would be very difficult to see anything without going to the terminal. So now let me go in the terminal mode. All right. And I can ping the Raspberry Pi remote IP address. For example, 192.168.2.104. Yeah, and you see this is working. So everything is going through that. A newly created session, but it's not over. Let's say I want to use my Modbus TCP client. So I can start a Modbus TCP client to receive streaming data from that Raspberry Pi. I just want to make sure that this IP address is correct. So that's 192.168.2.104. So let's connect. There we are. Let's start getting the data and view the data log. Okay, so what I have here is a streaming Modbus data over that Modbus TCP client that is going right from that PLC that is connected through SCA and which is exposed on this computer with its original IP address and original port number, so I can use that asset here remotely exactly as if I was directly connected in the same network with the same IP address, the same TCP port, exactly as if I was there. What does that mean for OT users? What does that mean for in the real world? It means save money, less truck rolls. Keep running your existing application like if you were physically present, but you're not present, and you keep all the security aspect and all the validation and the posture check and the user validation of Cisco Equipment Access, Cisco Secure Equipment Access. All right, now let's assume I am some IT person, and in particular, I'm interested about security, and some user is being connected. For example, here, this user started an SSH session on this computer, and this is not really something I was expecting. So as a security person, I can go to Access Management and check all the number of active sessions I have running. So for example, there is a session here that is, running at this point. That's actually this one. You can do two things. You can join the session, which basically means it's looking over someone else's shoulder. So the session you see here is the monitoring session. I press enter, nothing's going on. But if I go in this one, this is working. So this is my active session and this is my monitored session on the left. So you can actually watch over someone else doing something by clicking on join session. But also if you feel like this person is not behaving as it should, or if it's not expected, you can simply ask to terminate the session instantly and the session will be automatically terminated. Now you may wonder, my goodness, I think I arrived a little late and I don't know what this person has done on this computer, and I don't know what, basically what happened. So you can go to the session history and check what happened in the past. So who opened different session and when, and you can see the history of everything of what happened. So for example, I can go here and look, it'll show me exactly what's going on here. So you can see the detail and which device was used, and it was just, the session was closed, normally because of timeout. But also you can click here and view the recording, and it will show you what happened when this user was connected over that computer. This storage is not stored on Cisco Cloud, but the storage is a customer provided AWS S3 bucket. So this is where the video are being recorded, and therefore this is up to you to define your own retention policy for those recordings. Those recordings are yours. You'll keep them forever. It doesn't matter whether or not you are using SCA Cloud in the future. Those recordings will be residing in your own storage, and I think that's a very important aspect. Thank you very much for your attention. I hope that was useful, and if you need any kind of follow-up, please get in touch with your Cisco representative or Cisco partner, and we can continue the conversation and see how we can work together to improve experience for both IT and OT user with Cisco Secure Equipment Access. Thank you.